Next up, we have the centipede. So first off, both centipede and the centipede body have a factory and a pool. For the centipede body, it's very simple. We have create centipede body, which creates a number of segments attached to a head, and then we have recycle centipede body. The pool, fairly basic, again. The centipede head pool is also fairly basic, but the factory has a lot of functions and a lot of functionality. So these are base values. In case the designer doesn't put anything in the wave manager, these are the default values that will be set up. Next, these are the functions that the wave manager calls on to set these values appropriately, and these are the functions that the centipede, head, and body use in order to get their speed. Next, we have 4 different spawning functions. Technically 5, because we have spawn initial here, which creates the initial centipede. Create centipede, which isn't really used, but it will create a centipede at the specified position. Spawn head is a singular head at the top. Spawn from sides is called whenever the centipede reaches the top of the player area and starts to move down. It will spawn another singular head to add to the rest. And then upgrade centipede is when a body dies and needs to be upgraded. So that's the factory. Both centipede body and head inherit from a centipede base. It has some common forward declarations, some common headers that are needed for the headers, and then we have some common functions. This is just to help us traverse through the list and set everything up appropriately. For example, the head, when traversing through the list, we might want to get next, get next, get next. But if the head doesn't have a get next, so instead we'll end up returning 0 because the head's the end. There's nothing else there. But we will still need this function to work across both of them. Next up we have the centipede header. So we have our basic initialize, 3 different initialize functions, again depending on how the centipede head is initialized and spawned. Update, draw, destroy, collision, some get functions, and then we have functions to help us, again, traverse through the list. These are all overrides of the functions we saw in the base class. Next we have some basic game object stuff, things to help us with movement, our previous pointer, and then some more things to help us with movement. And 2die ties into the death, but we'll see how that works. So, centipede head. Again, in the creation, it has all of this stuff, creating the texture, and we have the initialize. A lot of code, not a lot. Some code is shared. So for example, 2die and prev get set appropriately, but here, previous is set instead to the previous were passed in. So while there is some lines that are shared, there's not much room for condensing the code. So, initialize basically just creates the head at the top and gives it a random state to either move left or right. Initialize from the side, it will figure out where it is. If it's, at the left side of the screen, it'll move to the right, and if it's at the right side of the screen, it'll move to the left. And if it's upgraded, it just takes the position from the old centipede and inserts itself into the list and updates all of the previous pointers appropriately. So, how does movement work? Well, we have our centipede move states here, and it's a lot. So this is what the move class generally looks like. We have an offset array, which is just 3 floats, x, y, z, for x, y position and then rotation. And then we have get move offsets and get next state. Get move offsets will return a x, y, z to add on well, first, let's move back. So, pixels per frame. Every 16 pixels, we are in the middle of a new cell. And at that point, we will check the cell ahead of us to see if we can move there. And then we'll get the next move state based off of that. Next, we will set our previous cell to our current cell. So, if in our box, we are in the middle, and previous cell is set to that position. Next, we take the pixels per frame, and we go into the movement list. Like we discussed in class, this is simply added onto the previous cell until we reach a new cell. So if we're moving straight left, for example, if we're moving at 1 pixel per frame, we'll first call this, so we add -1 to our last position. Then we add -2 to our last cell position, not our current. -3 to the last cell position, -4, -5. If we're moving at 2 pixels, -2, -4, -6, and so on. And this allows us to do any speed so long as it's divisible by 16. So 16, 8, 4, 2, and 1. Those are the speeds that are allowed. So, we will update accordingly, according to the pixels per frame. And we can see this in the update. So our movement index is where we are currently in the array. And we add on how many pixels per frame we're doing. So we'll go from, say, 1 to 3, and then 3 to 7 to 9, 11, 13, and finally 15, which is the maximum index in an array of 16. And you can see here, previous cell.x offset plus current offset. We're not doing our current position, we're doing the last cell we were at. And that's so that we can do variable speeds. If we reach the maximum, we'll explain this in a bit, and then we get the new offset and set our cell accordingly. So, if we look at our movement list again, you can see things like the turn up and right has a lot of values, and these are all pre-computed, hard-coded, it's fine. The Z rotation, the one quirk is for the previous cell is the Z rotation. The offset arrays carry the information of how much the sprite should be rotated. We don't track our previous rotation. This is just to prevent any oddities with rotations getting mixed up, because there was a bug previously. So now they just have what rotation the sprite should be at. So if you're moving to the right, 180. Otherwise, if you're moving to the left, the rotation is 0. And that's basically all of the move states. As I said, we have the move. If we look into the get move offsets again, we return offsets. But each of these has a custom get next state, which checks appropriately. So for example, if we have left and down, which is just moving straight left, we'll check the position to the left of us, and then we have different, we return different states depending on what we get. It's also important to note that the states are returned as pointers. They are static. If we look into movement list, for example, the offset arrays are static. And like I said, they're returned as pointers, so there's only one of each of these. And when it's passed down the list, it's also passed as a pointer, so that the centipede bodies are effectively sharing one of the offset arrays. So that's movement in a nutshell. Hit top, draw, destroy. We will get into these two later. Critter list we'll talk once we've covered all the critters, and the game manager checks centipede dead, we'll talk about later. The one oddity with the centipede is this. On collision with a bullet, we do not immediately die. This is due to a fact that the centipede bodies don't have this. This is a quirk with the head. I managed to move the bodies away from this method, but I haven't figured out a way to do this for the head. So for now, I have this clunky setup where on collision with a bullet, we queue ourselves up to die, basically. And once we've reached our maximum index, once we're in a new cell, we just execute the death code and upgrade our previous, send the score command, yada yada. It doesn't work too well, I'll be the first to admit. However, as I said, I figured out a way to move the body away from it, but not the head. So, in the worst case scenario, it will take 15 frames for the centipede to officially die. Because if it's moving up 1 pixel per frame, it'll take up until it reaches the max index of 15. That usually doesn't happen, however, it can. So that's one of the downsides for this method. And like I said, I was trying to move away, but I never got around to it. The body is in many ways similar to the centipede. As in the way that game objects are similar to each other. Draw and destroy. It has move update, which centipede calls every update, so that every body only updates after the one in front of it has updated. We have all these list management things, some move states, and then some death. Some stuff dealing with death. Again, we have movement. We've already gone over movement, so I'm not going to go over it again. Here it's very similar. Movement gets increased according to the previous cell. We don't have 2 die, so we don't need to worry about that. And so on. Centipede body only has one initialize function because it's only ever called one time, as opposed to the centipede head getting spawned multiple times. So the centipede body just attaches itself to the head in the correct position within the list, and then it has a state nothing as it waits for commands from the head. So, how does the centipede body deal with death if the centipede has that clunky kind of 2 die? Well, you'll be happy to know that on collision with a bullet we do split, which is effectively the centipede dying. So, when we go to split, we do something called final move. Effectively, we snap ourselves to position in the next cell. So if we have just started a new movement and we're hit by a bullet, that segment and every segment after it will immediately snap up into the final position as if they had just completed that movement. So they'll snap into position, and then we can easily work through the rest of the code. We can easily upgrade to a head without having to worry about transferring over the current state and the current position as well. We'll be able to easily spawn a mushroom when talking with the player, the mushroom manager. And then we have some upgrade to head, list management stuff, and creating an explosion. So, that in general, that's how the centipede works.